Just kidding. Um, Good evening, everybody. Thank you for joining us tonight. My name's Morgan Alonji. I'm with Conservation Nebraska. And tonight we've got Laura Johnson here with us. A few things to go over for the Zoom presentation tonight. Video cameras and microphones have been turned off on everyone's end. But if you do have any questions, we do have the chat box below or the Q&A section. We will go over those towards the end of our session here, or if it's something that we can touch base on while we are doing the presentation, we can pause to answer those too. As well as towards the end, we will launch a poll for everybody to take. It's just a survey. It helps us continue to run these programs for Conservation Nebraska. If everyone wouldn't mind filling that out, that would be wonderful. And we are recording this session as well, so it will be posted up, at a later date if there's anything that is missed. And then I will hand it over to Laura and we can go ahead and get started.
Okay, sounds good. I'm gonna go ahead and attempt to share a screen here. It says the host has disabled screen sharing.
Oh, sorry, one sec.
Thanks, Trey.
Yep, I believe. Okay. Did that work now, Laura?
Yes, it did.
Okay. Apologies for that difficulty. Sorry.
Sorry about that, guys. Okay.
Okay, so are you now seeing the first slide?
Yes.
Okay.
You are good to go.
Yep, we can.
Very good. Okay, so Laura Johnson here. I'm the Drinking Water and Groundwater Division Administrator for the Nebraska Department of Environment and Energy. I'm going to give a brief overview of the state's drinking water program, do a little dive into PFAS as an emerging contaminant, and then look at a state nitrate study that we completed last year. Okay, so what you're seeing here is essentially the drinking water program as a whole. And we have two different teams that help us run the drinking water program. We've got a monitoring and compliance team and a field services team. And so there's a representative from each team that goes in and manages a field area. So you're seeing the state of Nebraska broken up into 8 field areas, and then the monitor compliance and the field rep for each area. On the right-hand side are my supervisors for each team. So Andy Kale there supervises field services, and Taylor Benzel is monitoring and compliance. And then they each have an administrative assistant that helps. So their contact is on the left side there. So operator certification under Andy is Lena, and then emergency contact lists, which are required for each public water system, is under Caitlin within monitoring and compliance. So these teams, I'm going to break them down a little bit more into what they actually do. So I'll cover them individually here in these two next slides. So I'm going to move a bar here so it's not in my way. There we go. Okay, so the monitoring and compliance team works with the system from the very beginning. So as they are looking at building a new system, they're with them as they make it through engineering and are good to go for beginning to operate. So they come to us for an operating permit. And before we approve that permit, they have to test and meet all of the Safe Drinking Water Act maximum contaminant levels. So this team, they coordinate with the system and the Health and Human Services lab. They essentially develop monitoring schedules, and they work with the systems to go out and collect. If they need help with how do they collect a sample, Then they analyze the results. So they come directly to us from the public health lab. And if the system decides to go with a different lab, they will send them directly to us as well. And this team does the crunching of what the values are compared to the Safe Drinking Water Act levels. And they coordinate with the systems for any violations. So if a team if the team were to find a violation, essentially the system, depending on if it's chronic or acute. So if it's an acute violation like bacteria or nitrate, it is a 24-hour turnaround. So we're working with the systems, they're issuing public notifications, they're doing everything to get the public the information they need so that they can make an informed decision. These assessments and enforcement aren't just a water quality. It could also be a treatment technique or a paperwork violation. So for instance, there's a rule called the Consumer Confidence Rule, and that requires reporting to all of the customers on an annual basis. So if a system does not do that, they'll get enforced upon for that type of a violation too. And then this team works on special monitoring projects. So PFAS is one I'll talk about, but manganese was another one they've done in the past. So when the federal government's looking at regulating something, and we want to see if it's going to impact us, we do special studies here in the state to see the reach of that. On the flip side, the field services team, they actually live out in the field areas. So they are going to systems, they're doing the actual in-person inspections on a routine basis, but they're also helping when we have emergency situations. So they're out there, they're the first responders. It doesn't matter if it is Thanksgiving or Christmas or the middle of the night, they respond immediately. So they really are our boots on the ground team for helping our systems. So they also help teach. So we do have a siloed program, one individual that does operator certification and training, but everybody on this team and the monitoring and compliance team, they all help with education. So they give talks like I'm giving today at conferences and at actual training events. And then we do actually have classes. So we teach and test and certify and license all of our 1,500 water operators in the state. The other siloed program here is capacity development. It's a one-man show, a one-woman show for us. She provides direct and indirect assistance to these systems. So it's TMF, it's technical, financial, and managerial capacity. So she organizes or directly does training for new operators, new board members and owners of a system. And if a system is under an administrative order for violating something in the Safe Drinking Water Act, it triggers some education requirements too. So she helps with all of that. And then the last program under field services team is security grants. So this is a $10,000 grant with a 10% match. And it goes for anything for backup generators to fencing and helping with cybersecurity updates. So we give these out every year. Essentially, we have about $400,000 on an annual basis that we can give out to help our systems be more secure. So this is, I'm going to jump into kind of the makeup of our water systems. So let's see here. This is a makeup of all the public water systems. We have about over 1,300 systems and half are community water systems. So on the pie chart to the left is the breakout of those systems. So we have community water systems, which everybody knows is like City of Lincoln. There's also transient systems. So this could be gas stations or rest areas. And then we have non-transient, non-community systems. So this could be a school that's on their own well. It could be a restaurant, somewhere where there's a group of people that are coming again and again. So either workers or students, but they don't live there full time. And then on the other side is the same group, but they're broken out by the population served. And I think this is important because EPA defines a small public water system as one that serves 3,300 people or less. And you can see that in Nebraska, that's most of our systems. So this pie chart, again, is just looking at community water systems, and you can see that we have majority very, very small communities. So these are mostly villages here. Let's see. I think on the last point I'd want to make is that 80% of Nebraskans do get their drinking water from a community water system, and the other 20% are on private domestic wells. So let's look at the source. So this is taking that same group of systems and looking at where they get their water from. So the gray portion of this pie graph, as you would expect, is groundwater. We're a groundwater state. We mostly drink our groundwater. You can see the tiny sliver of yellow is the surface water systems. We have 5 surface water systems, and then about 60 systems that purchase water from them. And then there's another classification of a system called groundwater under the direct influence of surface water. And so these are systems that may be pulling water from an alluvial along like Lewis and Clark Lake or the Missouri River. And so they're treated as a surface water system in terms of what we make them do to treat the water, even though they're pulling water from the ground. So the other pie graph is the same group of systems, but now it's looking at, again, the population served. And I think this is a really important slide to show people because those 5 surface water systems serve a majority of the Omaha metro area. So you're seeing that 600 and nearly 20,000 people that drink surface water, and that is mostly from MUD's Florence treatment plant. So they tie in, the MUD has multiple sources, but anytime you tie in a surface water source to a groundwater source, you have to treat it as surface water. So again, on the pie graph over there, the other big bulk is groundwater and those GWIDY systems, groundwater under the direct influence. So it's a good mix of sources, even though the bulk of our systems are very small groundwater systems. And I have the same information here in a map so you can see the distribution. So the colors of the dots correlate to the left-hand side. It's kind of covered for me, but it does kind of show you that the surface water systems and the ones that purchase are the green and yellow, I believe. I'm going to look here for a sec. Yes, and then GWIDY is orange, and then the bulk of those gray systems, again, are groundwater systems. So what's covered under the Safe Drinking Water Act? There are 9 rules. They're called National Primary Drinking Water Rules, and they have 94 contaminants that they regulate. And then this applies to public water systems. It doesn't matter if it's a public, like a city, or like Beaver Lake, like a privately owned group that has their own treatment system and distribution system, whether or not it's publicly or privately owned. If you're serving people who are living in this community, the same source of water, it's a community water system. This does not cover private domestic wells, so they are not regulated by the Safe Drinking Water Act. Congress left that up to the states. Okay, so here is now kind of a screenshot, a shot in time of what the state looks like in terms of compliance. So we meet with EPA on a quarterly basis, and we go over all of the systems that have violated the Safe Drinking Water Act. And so these are corresponding, the dots are corresponding color to the rule that they're violating. And so you can see that we have back probably in 2017, 18, we were mostly dealing with health-based violations related to the groundwater rule. and arsenic. So coliform bacteria and arsenic. And then you can see that if you're looking at the chart on the bottom, it's breaking those up between MCL violations and treatment technique violations. So the MCL means that the chemistry of the water violated. A treatment technique may be that they did not follow a specific procedure, but it doesn't necessarily mean that they violated an MCL. And so you can see that that's kind of corresponding to the groundwater rule. That was a new rule came into play. So it took some time for the systems to understand requirements and to zero those in. But you can see as those ticks off, so do the treatment technique violations. And then you see an uptick in the MCL violations, and those directly correlate to nitrate. So the nitrate is not something that the system has control over. So I like to show this slide because I think it shows that our water systems are doing a really good job. Our water operators do a really good job, and that the issues they're facing are outside of their control. So this next slide talks about administrative orders. So when you see those violations, multiple violations lead to an administrative order. Nebraska is very fortunate in that we have pretty good water. Of the 94 regulated contaminants, we only violate 8 of them. However, nitrate, because we're an ag state and we farm and we use our water for ag purposes, we do have issues with nitrate, and you can see that corresponds to the largest piece of this pie graph. So we have 7 systems that are currently violating for the nitrate MCL, 2 for arsenic and 2 for uranium. Those 2 contaminants are naturally occurring in the groundwater. Again, is not the system's fault. That is just the way that it is. We live in an area where this is just coming from the bedrock geology. And then the last one is a disinfection byproduct. And that corresponds to a system that pulls water out of Lewis and Clark Lake up in the north. And so that is just zeroing in on the chlorine byproduct from treatment. So this next slide is the next 2 actually both have these QR codes. So this is Drinking Water Watch. You can scan that or punch in the URL there, and it'll take you to a database that you can search by system name. So I have Lincoln up here. I live in the city of Lincoln. So I just pulled that one up as an example. But it'll tell you everything from the operator's name and their phone number, as you can see here, their email. It talks about the system's facilities, their sampling schedule, any inspections that they have, and any Safe Drinking Water Act violations would be in here. So if you take the water system number, that NE number, you can then plug that into this next part here is the public record search. So if it says that there's a violation, but you want to actually see what the violation is, you can punch that NE number in and it'll bring up all of the records that we have associated with that facility. I'll caveat this in that the drinking water program came to us from HHS back in 2021. And so the records prior to that are not part of this online portal. But anything going forward, we began to keep electronic records of. And if you're interested and you want to know the history of a particular system, you can always get a hold of us and we can pull paper records for you. So that's not a big deal. We have all the records, but these ones are just accessible to the public as long as they are not protected. Okay, so this is my last slide of just like an overview of the program. And now I want to talk a little bit about PFAS, which is one of our emerging contaminants. Oh, let me go back. Hang on, there we go. Okay, so I'm sure most of you have heard the word PFAS by now. It is a large group of man-made chemicals, per and polyfluoroalkyl substances. It was accidentally discovered in a lab in the 1940s. and found to have amazing characteristics of being water resistant and soil resistant, as temperature resistant. It doesn't wrinkle. It reduces friction. And so it had all these amazing properties. And so they put it in everything. And so it has been in all of our consumer products for most of our lives. And so I imagine that I'm probably wearing some stuff right now that has PFAS in it. And we do know that EPA and other organizations are slowly phasing PFAS out of their products, but it is everywhere. The other thing with PFAS is they call it the forever chemical. And that's because it is a really slow to break down. PFAS has a half-life of about 35 years. And if you compare that to nitrate has a half-life of 8 hours. So when it gets into the system, the food chain, it persists for a very long time. So PFAS has several health impacts that we're concerned about, mainly to the reproductive and developmental aspects. It does increase your risk of cancer and has some indication that it does lead to damage of the immune system and possibly the liver, as well as some interference with hormones and cholesterol. EPA's final drinking water regulation decided to regulate 6 PFAS contaminants, and we are seeing for the first time ever a hazard index. Hazard index have been used in the Clean Water Act, but not in the Safe Drinking Water Act before. But that's just an acknowledgement that when you mix these PFAS chemicals, they're more harmful in a mixture than they are individually. The PFAS hazard index is something that my monitoring compliance team will calculate and then inform the systems of. So they don't need to figure out how to do this. All this happens internally through the department once this goes into effect. So the state has until April of 2026 to either take primacy of this rule or to ask EPA for a primacy extension. The reason I mentioned this is I'm not going to cover it tonight, but there are 2 other lead rules. One's in place right now. There's a second lead rule that will go into effect in 2 years. There's also the consumer confidence rule, and there's a water systems restructuring rule. And so for us to open our regulations again and again and again is just not feasible. So we are attempting, like most states, to do a primacy extension till where we can bundle them all together and then do one update at the same time. So I'm going to talk a little bit about what the department and the EPA have done about PFAS as we're gearing up to take on this new regulation. So EPA has something called UCMR 5. It's the unregulated monitoring compliance, the unregulated compliance monitoring rule. It's the 5th one of those. And so under this rule, EPA decided that they were going to test all of the water systems that served more than 3,300 people. In Nebraska, of the ones they've tested, there are 3 systems that are over the MCL for PFOS and 1 for PFAS. And I think this is a really interesting map because you can see that there are states where there's so much PFAS, you can't see the state boundaries. But here in the Midwest, you know, like I said earlier, we're an ag state, we're not a manufacturing state. And so we're dealing with ag chemicals, not these industrialized chemicals like you see on the coast. So this is our state program. We mirrored what EPA did, and we essentially offered the same sampling to the rest of the systems. It's a voluntary program right now, but it does count as initial monitoring for when the rule comes into play. And I'll say that these are very expensive samples. You have to test each source, and the component sampling is of 29 PFAS and lithium. So it takes about $800 a sample. And right now we will pay for your first 2 samples. So there's also the issue of the lack of labs that have the capability of testing for PFAS. So right now we have a contract with PACE, and we send these samples out of state to, I believe, Minnesota. I know Kansas just built a lab. However, they haven't assessed their situation, so they don't actually know if they have capacity to help other neighboring states. So we may just keep going with PACE in the future until our lab, if they decide to take on PFAS, gets up and geared and ready to do that. I do know that it takes about a year once your lab is built to be certified by EPA. So there is some time to get going on it if the lab decided that they wanted to do that. But right now we'll probably have to pick an out-of-state lab to help us with this. So of the results for Nebraska, we have about 92% of our systems have sampled, and as you can see, only 7 are violating for PFOA. We did have 17 for PFAS and 5 for Gen X. So really not that bad. Some of these systems think there may be a reason that they're seeing it. Like they, for instance, one system said that it may have been in the tape they used to connect a port for sampling. So, they may have to remove that. So there's some trial and error. Hopefully these systems don't have it because, as we said earlier, it is a forever chemical. So you're either going to have to treat or find a different source. So right now, if you get 2 samples that come back above one of the PFAS MCLs, the team is going to go out and sample for the system just to make sure that it's not a sampling error. PFAS is, like I said, it's everywhere. So if you wash your hands with a particular kind of soap or, cleaning whatever, maybe it's one of those you've got really rough hands and you're using, like my husband does as a plumber, or something that really gets in there. There could be PFAS in that. It's probably on your clothes. And so, there is a chance that some of these could be false positives. So we've also been trying to figure out, outside of just the drinking water systems, where is PFAS in Nebraska? And so we've been working on this for quite a while. 2017, our Superfund section decided that they needed to get an inventory of all the locations that could possibly have PFAS. And so they started a statewide inventory of sites that had potentially used or manufactured PFAS in the past. And so they came up with essentially 990 facilities that could potentially have PFAS. So of those systems, they have done a Superfund site assessment for 20 near all of the municipal airports. And if they found it, they then followed up with soil and private well testing to see if they could detect it nearby. This and a few of the other things I'm going to talk about are not finalized, so I don't have a study to share just yet, but we will. We're actually in the middle of developing a PFAS webpage that will then eventually take you to all of these studies that we're doing. So this is just a map of those 990 facilities and where they're located across the state. So pretty widespread. Okay, so we also were looking at a project with UNL. It's still ongoing. So this project is looking at sampling PFAS in wastewater. So we're trying to get an idea of the discharge from these wastewater treatment facilities to see if there's any seasonal differences, if there's different treatment processes that are taking care of the PFAS. And then finally, we want to see if UV is treating any of those compounds. So UNL has done 20 wastewater facilities so far. They've looked at influent, effluent, and biosolids. And then they are essentially going to do a report. I think UNL has till May of 2026 to finish this and get us a report, but this will be another interesting one, and it'll help us figure out what advice to give our wastewater treatment facilities and to see what's coming into the streams. Okay, so my last slide on PFAS is on aquatic life. So in 2022, there was a proposed aquatic life criteria for PFOA and PFAS, looking at aquatic toxicity data. This one was looking at essentially the effects to the aquatic life themselves. Then we had just this past December, they issued in the Federal Register a federal human health consumption criteria. So now we're looking at how this bioaccumulates and then how someone who eats the fish is impacted. Again, this is just hot off the press. I believe that draft criteria maybe has been out for a few weeks. So our surface water team is just now looking at this rule to see how this impacts the sampling that we do, and to see if this is something that, again, like the EPA lab may be interested in analyzing for us. Okay. So the last major topic I wanted to cover today goes back to a bill that was introduced last year on behalf of the governor that passed, and it gave the department $1 million to do a water quality study. And in particular, we looked at drinking water sources that were impacted by nitrate, both those that are regulated and not regulated by the Safe Drinking Water Act. So we know that there's a lot of good work that UNL, NRDs, and other entities have been doing to figure out how nitrate got out there, what we can do to reduce it, to get it out of the groundwater. But we're not trying to replicate that study or those studies at all. This one was specifically, it's already out there now. What do we do about it? So we use our groundwater for agriculture here in Nebraska. And so what you're seeing on the left is a map that comes out of our groundwater report to the legislature. Actually, they both do. So this one is looking at, the one on the left is looking at the most recent data from a well that had data between the years of 2003 and 2023. So it's just taking the most recent sample from any groundwater well that had a sample. And you can see that the red dots are over the drinking water MCL of 10 milligrams per liter. And then on the flip side is a map of the public water systems that are either already treating for nitrate or that are on quarterly monitoring. So you're on quarterly monitoring if you're more than half the MCL and you're trending up. So if you drop, so you're 8 milligrams or you're trending up towards an MCL violation, you'll stay on quarterly monitoring. If you drop down below half the MCL, we'll drop you off. So there are a significant amount of systems that haven't yet violated, but we are keeping an eye on. So the study here, again, is looking at water that is used for drinking water. So we're looking at both public water systems and private domestic wells. We do know that about 1 in 5 or 20% of people get their water from their own private domestic well. And so this group of people historically, if they don't sample their own well, we can't require it that they sample. And so they may not know what they're drinking. And why it's important is because nitrate in the body is very toxic. It's toxic because it converts to nitrate and then it limits the body's ability to to move oxygen and utilize oxygen, because the nitrite binds to the oxygen, and that leads to blue baby syndrome, which can be fatal in infants. So this diagram here is just kind of showing you that once you ingest the water, it goes down into your stomach, and then your stomach pH actually has a little bit to do with it. So infants and adults that have, gastric issues have a higher pH level, and that actually supports the growth of the bacteria that converts the nitrate to nitrite. So once it's converted, you can see here, as you're going back up the flow chart, what that does to the body. So you start to have nitric oxide and ferric ions. And then at the top there kind of shows you what a healthy blood cell looks like. And then one that has the extra nitrate binded to it, and what that does to the system. So let's go ahead and look at some tools. So the study essentially had us look at what was going on and figure out how to help systems and private domestic well owners address the issue. And so what you're going to see here are system reports. So what we've done is for every single system, they all have a community water system that has a wellhead protection area. They all have a report like what you're seeing right now. So the report is giving them an analysis of essentially what their wells are doing and the wells that are within the wellhead protection area that are not their wells. So this one's a good example to show, because you can see the dark blue dots are the community water system well, and you can see that there's all of a sudden a drop in about 2010. And so that tells us that essentially they did something. They took a well offline, they drilled a new well, maybe they started blending, but you're not seeing that uptick like you were. So it looks like they took one well that was nearing 10 milligrams per liter offline and drilled a new source. But this does show you up on the top, the image of the well protection area, all of the wells, and they're color coordinated to the level of nitrate. So it gives you an idea of what's going on within your wellhead protection area. There's also an R² value, and that tells us, we can plop that into a formula, and that can tell us essentially when they may violate. So, they're not now. This one in particular is trending down at this point, which is great. But if you were to be trending up, we could use that R² value to say, okay, it looks like maybe in about 15 years you're going to violate the MCL. So you've got some time to do something about it. So on the right side is a tool we developed. It's very complex. It's essentially an offshoot for a system to not violate the nitrate MCL. So when we're hitting certain things, certain trigger levels, like for instance, that trigger level, the first offshoot is when you have a sample that is greater than 5 milligrams per liter. And so at that point, we want to start talking to you about wellhead protection, source water protection, education, getting out there and doing some stuff in your well protection area to slow the increasing trend and hopefully stop it. When you're above 5 but below 8, that's when capacity development comes in. We probably want to educate the board, let them know what's going on. You may want to start preparing to be financially in a point where you can take on a loan. So we start talking to the state revolving fund people and figuring out what their needs are. And then if you're below 10 but above 8, we're going to have you do all those things, but we're also going to have you start to prepare an application for assistance. So if you violate the MCL and you're under an administrative order, it's very rigid. You essentially have 3 years to come back into compliance. And usually this takes a very expensive engineered solution. So you're drilling a new well, you're building a treatment plant, you're connecting to a neighboring systems. Those are all very expensive, and we want to try to avoid that. So this is that same grouping, but I'm just showing you here how they all fall into our priorities for short-term, moderate, and long-term. So these are our buckets that we're going to be working with. And if it says that you're not a candidate for outreach, it's because we've already talked to you. You're already doing something, you're already working with us. So no one is just not a candidate. Everyone, you can see everyone is a candidate to come in and do something to protect their drinking water. This slide here was a model that the department built to go into the next tool that I'm going to show. But because we don't have data everywhere and we have very little data from private domestic wells, we essentially had to build a model. So this model has 18 different parameters that went into it. Anything from, the construction of the well to the geology to the land use. But this model is running in the back to a private domestic well risk assessment. And so I'm going to show that right now. So this GIS risk assessment tool is something that the agency and partners will use to educate people about what their risk level may be. So you essentially can drop a point, you can enter an address, and then it will run a bunch of queries on the background. It'll look at any neighboring or nearby facilities that are permitted. It'll look at, again, everything in that modeling document that I showed, the 18 different parameters. It'll look to see if there's actually a well that has been sampled where the sample has been supplied to the clearinghouse. It'll pull that up and say, it looks like you have some data from neighboring wells and your average nitrate area or your average nitrate concentration in the area is X. It always, here's the other one. It always tells you to sample your well. So we're always trying to get you to sample so that it's not just an assessment with some models, but you actually have real data to make your own assessments and decisions with. So there's a box in the corner that will take you to the Health and Human Services lab that you can order your own kit. And then there's actually a 4-page assessment that this generates. This is just an image there showing you that it's going to give you a range, a risk assessment range, and then it's going to give you some groundwater flow directions. So if you're looking at this area and you can see that it's your house and the groundwater flow here for this example is south, mainly south, a little bit southeast probably. But if you're looking at this and you're seeing that your septic system is directly upgradient of your well, you may be causing your own problems. So this really is just a good tool to get people to think about what is around them, what can they do, is there anything they can do? Do they need to put in maybe an RO system? Because those are relatively cheap. We've had some assistance available, and NRDs have a lot of assistance available for RO systems for your home. So this is just a really great tool that we're excited to get out there for everyone to use and help those people on private domestic wells. So my last slide is just a little bit about the things that we do here. So I've mentioned wellhead protection and source water protection. So those are both programs that we will go out and provide assistance to a community to help them protect their source water. So we actually have grants available where we can decommission wells, we can do education. There's a few different things that you can do with that pot of money. But there's also a non-point source program or 319. And these will do up to $300,000 a year per project. So these are bigger scale. Maybe for instance, you wanted like the Highboy demo, you want to try an interseeder or something like that to try to get people to change their agricultural practices. So these are mostly geared towards ag, because that is what we use our groundwater and our land for. And then again, I've mentioned the state revolving fund, and those are grants or low interest loans that we can give to our regulated community, so our municipalities. So I think that is my last slide, and I will go ahead and turn it back over to Morgan and answer any questions you guys might have.
Awesome, thank you. I have a question, but there is also one in the Q&A, so I'll go ahead and start there. The question is, are water contamination guidelines federal government, and is it the same for all states?
So the federal government does create the MCLs, and so a state can be more stringent than the federal government. In Nebraska, we don't have the resources or staff to do what the federal government does when they're coming up with those MCLs. There's a lot of studies that go into it. It takes many, many years. But there are larger states that have much bigger programs that will do this and set their own MCLs that are more stringent than the federal ones.
Okay. We also have, it's more of a comment, but it just does say that you covered a lot of ground very effectively. Great job. And it's Joe says, I'm sure you'll have nitrates under control soon. So
Thank you, Joe.
let's see, we've got a couple more. Somebody's just asking, where do the nitrates come from?
Yeah, so there's been a lot of studies done in Nebraska, and mostly it's commercial fertilizer. So depending on where you live in Omaha, that could be because you put it on your lawns. Out in rural Nebraska, it's because they put it on their crop fields. So it is mostly commercial fertilizer. There is manure that people use, but that's not really the bulk of what we find in the groundwater. It's that like anhydrous ammonia.
Okay. Okay, this one, there's a few parts. Vern's asking, how can I test my water for nitrates? Can we stop fluoridating our water? And then can Nebraska start growing, more hemp to lower our water use and pollution from GMO corn?
Okay, I'm gonna take the first two.
Okay. Yeah, a three-part.
Yep. So the Health and Human Services, if you just Google Health and Human Services Public Health Lab, there is a section for the public. And so you would just follow along and click the right buttons that you're from the public, you want to test. And so it'll give you some options. And essentially you would work directly with the lab. So once you fill that out, they would send you a sample kit. You would sample accordingly. So sometimes there are holding times. Let's say you wanted to do nitrate and bacteria. So you need to do it according to what they have on the sampling sheet and get that returned within the time frame. And then they will send you the information directly. When you go that route, that information doesn't necessarily end up in the state's database. Because it's not our data, it's your data, but you could, if you want to help with the study and the tool and make it more effective, you can submit that data to the clearinghouse once you get it. But that's a whole other thing, and we could talk about that if you get to the point where you have a sample and you want. But essentially, it's not us, it's the health department that can test your well. Fluoridation. Fluoridation is, there's two things to fluoridation. So there is a dental health fluoridation level, and so that's actually fluoridation is dental health. So that program's actually with Health and Human Services. But then there's a much higher level, and that level is the Safe Drinking Water Act level. But even when you add fluoride, you never add fluoride to the water system at a high enough level that you would violate the Safe Drinking Water Act. I do know that there's been some bills introduced to the Nebraska legislature talking about fluoridation. But again, that's not my agency. So if you want to look at it and follow along, I think the legislature has a bill tracker. And again, I'm not sure, maybe Carla remembers what that bill number is and can throw it in the chat or unmute and chime in. And I'm gonna have you repeat that the third question.
Excuse me. Yes, it says, can Nebraska start growing more hemp to lower our water use and pollution from GMO corn?
There was, so hemp is, again, this would be up to the individual farmer to decide what they want to do in their business. But I believe hemp has been grown in Nebraska. I thought over by maybe Plattsmouth or Beaver Lake, there was some hemp farms, and I don't think they were very successful. I don't know that they lasted more than a year or two. So unfortunately, that's outside of what I can control. So.
Another question we have, Holly is asking, in general, what do you recommend is the safest way for residents to drink water? For example, boiling water, filtration, purchasing from the store.
So there is not one general recommendation. I would never say boil your water no matter what, because for instance, if you have nitrate, boiling the water concentrates it. If you have bacteria, boiling the water kills the bacteria. So it really depends on what specific parameter you're trying to address. So there's not a one size fits all. I would say that if you're on a community water system, I would look them up. I'd go into Drinking Water Watch and look them up and see if there's any violations that I might be concerned with. And then I would, at home, I live in Lincoln. I don't drink water out of the tap. I drink it out of a filter, my filtered fridge water. So not that filter is doing, amazing things, but it's better than nothing. So, and being that you're on city water, they have to comply with the Safe Drinking Water Act. So I'm not really too worried about my drinking water here in the city of Lincoln.
Got it. Trey, if you want to go ahead and launch the poll just while we're wrapping up, that'd be great. And I was just gonna ask, I know that with private wells, it's not required to have those tested, but are you finding there's an increase, at least in interest, or that people are getting it tested with some of these RO, how do I want to word that? With the incentives they're doing now to get those RO systems put in, or is there like a general reason why maybe some folks are hesitant to test their private well water?
I would say that through the nitrate study, we did offer a free sample. So we did postcards directly mailed to, I think, something like 29,000 registered private domestic well owners. And then we did some public outreach, and we got about 3,700, maybe 3,800 almost, people that took us up on that, and they got a kit and they sampled. Of those 30, we'll just say 3,800 people, 15% of the samples came back above 10 milligrams per liter. And then we did a direct phone call to everybody and told them about our program at the time. It's done now, but we had an RO program under ARPA funds. And so we had $1 million and we spent all of it on private domestic RO systems. There is it's not through us. Oh, Carla, I'm not sure if you remember this either, but there is there's like a tax rebate thing that goes through the Department of Revenue. So you can get an RO system and get a tax rebate. And then there's NRDs. Your NRDs most likely have some sort of cost share assistance for an RO system if you're interested in that.
Cool. I do have another question. Wondering, do farmers have to disclose high nitrates when they sell acres of property?
No, I don't believe anybody has to disclose anything. So if I were to have shown it there, I have a map from another talk that shows all of the private domestic wells that have been sampled. And there's a cluster around Lancaster County because the county requires you to test your water when you sell your house. So that's a county level decision. So I think that would be great if every county had something like that, or maybe the real estate agents had something where they pushed it. The other thing I would say is that for the first time ever, my kid's doctor asked me during their well child check if we were on well water. And I asked her, no, but why do you ask? And she said, oh, well, we just learned that there's something called nitrate and, it can affect, development. And so we just want to talk about it and see, if you were on well water, we would basically ask you, do you know what's in your water? So I think there's a lot of traction now, just in the last few years, a lot more traction than there has been about talking about it and trying to figure out how we can address this issue and protect ourselves from high nitrate water.
Perfect. Yeah, I've had the same question asked too, just recently, it is interesting to see the different aspects of life these are all falling into now. I mean, it's not just what do you know, it's what can we do and what can we do better and kind of being more aware. So it is it's an ever learning process of many new topics to know.
It is. Yeah.
But, well, that was wonderful. I don't see any more questions now. Just to reiterate, we did record this. It will go back up. Um, and I appreciate you for your time this evening and a wonderful experience of learning.
All right. Well, thank you and have a good night, everybody.
Thank you.